Alright, before we start the second part of the video on exception handling, let me give you an analogy. Now, yesterday we had seen that there are three keywords which are available in C++ to handle exceptions, and those are the try, catch, and throw keywords. Now, before we actually go and look into how they can be used, here's an analogy for you. Now, when you all come and write an examination, sitting in the examination hall, right? Everything is fine until you come and write the examination. Now the problem happens, and why we are present in the examination hall is when you start, or if somebody starts behaving in a way in which you're not supposed to. For example, if there is an unwanted scenario of somebody copying, then we have to deal with that situation, right? So in a normal scenario, everybody comes, sits on the desks, writes their papers, and then leave. This is a proper normal scenario without any exceptions. But when somebody starts copying, that's a condition which is unwanted. We don't require that condition. Now that is an exception. So what do we do? Well, as an invigilator, we move around the class trying to find any exceptions. If there are no exceptions, the entire examination runs off well, no problems at all. But there are chances of exceptions happening. There are chances of somebody copying. So what do? We keep looking around, we keep trying to spot any exceptions. Now what we do is we try, right? We try to see if there are any exceptions or any conditions which are not wanted. What happens when we find an exception? Now what happens is, if there is an exception which is happening, that exception can cause a problem for all of you. How? Probably looking at that exception, someone else might copy, and then someone and third person might copy, and the entire examination hall would become a chaos. Right, and it would be very difficult to handle, and probably you would have to close down the examination. So rather than doing that, we look at an exception and try and handle it. So what we do, we try to spot for exceptions. We try to spot for people who are copying. After we spot, or for example, we find that there is somebody who is copying. He's brought some chits and he's copying. Now we have found the exception. What do we do now? What we do is, from that entire normal flow of examination, we throw that exception. That means we throw that person and send him somewhere. And we tell him, go to Dean's ma'am's office. You will be dealt with there. We will deal exactly what to do with you there. So once an exception is found, we throw that exception. And when you throw something, obviously you have to catch it, right? So when we throw the exception and he or she is sent to the Dean's ma'am office, the Dean ma'am's office or the director's office will catch that exception and deal with it. What and how exactly it will be dealt, that's a different scenario. That means you can write a program to spot or try to look for an exception using the try keyword. If an exception is found, you need to throw it. And when you throw an exception, you need to write another block of code which will catch that thrown exception and handle it. And that is how the try, catch, and throw keywords are used in C++. So let's look at the try block first. Only errors which are occurring inside the try block can be handled. That means when you write a piece of code and when you don't have any piece of code inside the try block, and if there is an exception which happens there, we cannot handle it, right? Try block basically initiates the exception handling mechanism. So if you look at the syntax below, there is a simple try block, which try is a keyword in C++, and inside that you write all the statements. So the statements that you write inside the try block should be those statements where there are chances of an exception happening. Now that is again a programmer's view. You have to look into it, you have to do some analysis, and you have to figure out that yes, these are the areas or these are the piece of code where an exception can happen. Now once you find an exception, right, then we need to throw it to a place where it can be handled, and the keyword throw does that. So any potential exception found in the try block is sent for processing using throw. Right, now what the throw does is basically it transfers the control from the try block. So from the try block, the throw transfers the control to the catch block, and it will also take the exception and what exception has happened and what is the scenario. You can actually pick up that particular variable if he is causing an exception and throw it to the catch block where it is going to be handled. So an important point to note here is the throw keyword must be present inside the try block. Right, so if you look at the syntax here, you can throw from inside the catch block. Now the throw can be a constant, so you can actually throw a number, or you can also throw a variable or a variable of any type. It can be an integer, it can be float, it can be double, or any kind of variable you can throw from the try block. Right, what about the catch block? The exception which is thrown from the try block using throw, right, will be handled in the catch block. So the catch block basically contains the code of what needs to be done in case an exception happens. Right, it could be a simple code just to tell the user that look, you have entered the wrong value, so the program will end here, or do you want to go back and write and enter another value. So from the catch block you can send him back to a place where he can input his data. So that's the way a try and a throw and a catch block will work. Right, now let's look at a small example. So this is basically the mechanism in which these three work. So you have statement. Look at the right hand side, you have statement. Then identify the statement which could be a potential statement for exception handling, or where the exceptions can happen, and write them, and in case any exception happens, you throw that particular object, or you can even throw a constant. So assuming that there is an integer which is causing a problem and it causes an exception, so we throw that integer, and then there is a separate catch block where that integer which is thrown is handled. Right, so that's how exception handling mechanism takes place. Let's look at the simple code. Now it's a very simple program where we are entering two variables which are doubles, and we are computing the result x divided by y. Now this is a very classic case where there can be an exception. Now when can there be an exception here? In a normal scenario, everything will work fine. If the value of x and y entered is 5, 6, 4, 3, anything, it's absolutely fine until the value of y entered is 0. Because when you divide something by 0, there is a problem. Right, so this program will run absolutely fine until somebody enters the value of y as 0. Now in this case, if you run this program and you enter the value of y as 0, the program will crash. That means there is no code written for exception handling. So assuming that we want to use the try, throw and the catch block in this, right, so that the program does not terminate, wherein we can handle it and we can probably send some message to the user or anything like that. This is how we can change the code. Now the potential exception is happening here. So if you look at this code, this result is equal to x divided by y. That's the place where the exception actually can occur, because the value of y, if it's 0, exception will happen. So we need to put that into a try block. So if you look at this, we have put this inside the try block, and we have a condition here that if y is not equal to 0, then you go and execute your code like how you do it, no problem at all. However, if the value of y entered is 0, throw that value y. That means inside the try block we have put this throw. What it does is it will throw the y to the catch block. Now one thing that's important to note here is, since we are throwing y and y is a double, when you are catching that in the catch block, the catch argument should also be a double. It's something like that. When you're throwing a ball, there should be somebody who knows how to catch a ball, right? It cannot be, it should match, the argument should match. So whatever you're throwing, the catch block should match with the data type, because there could be a scenario where you have multiple catch block. So which catch block will be catching that y is a question, so you have to match it with the data type. So in this case, since y is a double, the catch block which is defined here is with a double, so this y will be thrown into the double, and now you can handle that exception in the catch block. So you can actually print the value that the value of y that you've entered is not correct and it is 0, and if you enter and if you divide anything by 0, you get an error. So you basically do not allow this program to crash, but you've handled that exception and you've given a message to the user saying that this is how the problem is happening, so kindly change the value or do whatever. You can even write lots of code here. You can send the user back to the place where you can enter values for x and y again, and so on, right? So what we've seen today is just a simple example of how try, catch and throw can be used. Important thing: try initiates the exception handling mechanism, throw has to be written inside the try block, right, which basically catches the exception and throws it to the catch block. So the whole purpose of throw is to take the program control from the place where the exception has happened to the place where we are going to handle it. That's the catch block, right? So just go through this small example, try and execute on your system, and then we will come back again with the third part where we will talk about multiple catch blocks. So see you for now. Bye.